Hi, welcome to lesson 9 in the series of 8051 microcontroller programming and interfacing. You can also, for more information, you can visit us at www.jcbrolabs.org. You can also download the required software for programming the 8051 microcontroller, and you can also view the web content related to this tutorial lessons on that website. In this lesson, we will talk about how to interface a DC motor to 8051 microcontroller. So, in this video, we will not go into the details how the DC motor works. We are assuming that you already know the internal architecture of the DC motor. We will cover up only some of the basics of it. So we say a DC motor is a simple motor which works on a DC supply. And DC supply has two terminals, positive and negative. So in sense, motor doesn't have a positive or negative supply. This depends only on the motion of the motor. For say, if we have connected positive supply of the battery at this terminal and negative supply at this terminal, for say it will rotate in one direction. Now if we change the polarity of the power supply, then motor will rotate in opposite direction. Simple. So in a sense that motor rotation direction is simply depends whether positive is connected at this terminal negative or the negative is connected at to the terminals. So there is no other need to run a DC motor. So one of the ratings of the DC motor is ratings like it will run at 12 volt or plus 5 volt or 6 volt motors, and depending on that it also have certain RPM ratios are like 100 RPM, 50 RPM or 10 RPM. So if the RPM is less, its torque carrying capability will be high, and if RPM high, its torque carrying capability will be low. So if we are targeting the applications like in which a speed is required, so we will consider our DC motor with a high RPM, and if we are considering for application which takes some weight, so we will take a motor with less RPM. So now we will see a DC motor, and we will change the connections and we will learn how DC motor works. So what we will do, we will first connect power supply. Let's erase it. So we will first connect suppose this is our DC motor, so we will first connect a power supply of 12 volt here like this, positive here and negative here, and then we will change the polarity of the power supply and we'll see how the direction of the motor changes with the change in the polarities. So let's see it. So this is the DC motor, and these are the two terminals which we have connected to the supply. So first we will connecting this terminal at plus 12 and this terminal at ground, and we will see. So right now it's rotating in one direction, so it is like a clockwise direction. Now we will change the polarity of the connections. At one terminal will be grounded and then another terminal will be connected to supply. Its direction of motion has changed, or now it is rotating in anti-clockwise. So this is how simply we can change the direction of the DC motor, whether it is running forward in clockwise direction or anti-clockwise direction, just by changing the polarity of the power supply connected to it. Now let's move forward with other theoretical description for connecting this DC motor to the microcontroller. So once the how to run a DC motor is finished, now let's see how to interface this DC motor with a microcontroller. Before writing the program for controlling the direction or for interfacing the DC motor to 8051, some of the basic hardware needs to be studied. First thing, DC motor is a high power supply and runs on a high power supply, and like it supply is or its rating voltage is nearly about 12 volt, while our microcontroller runs as plus 5 volt. Further, it takes high amount of current, high current while running, and there are limit on the powers on the current which can be provided by the microcontroller to this to any syncing device. So these are some of the reason why we can't connect DC motor to the microcontroller. For revisiting, we can't connect DC motor directly to the pins of the microcontroller because number first, DC motor require high amount of current which generally can't be provided by the pins of the 8051 microcontroller. Second, a DC motor runs of plus 5 volt, plus 12 volt at full speed ratings, while our microcontroller can provide only plus 5 volt power supply to the motor. So in a case, so we need some kind of some driver circuit. So we need a driver circuit which takes the signal from your microcontroller and then gives to the motor, and in turn our motor can run either clockwise or in anti-clockwise direction. So for DC motor we have this driver circuit, that is L293D. This is the DC motor control driver IC which is used to control, or which is used as a driver in between microcontroller and the motor. So it provides all the sufficient conditions which are required to run a DC motor, like high power supply and high running current. Now let's see the connection diagram of this L293D driver IC. So this is the symbolic representation of driver IC, L293D motor driver IC, specifically DC motor driver IC. So it has 16 pins plus 8 plus 12 power supply at which this motor needs to be operated, that is connected to the pin number 8, and this pin number 1 and 16 are connected to the plus 5 supply, and these are also acts as the enable pins of the mic of this port. That means if we want to enable this particular port of this driver IC, one needs to be connected here. Similarly, if we want to connect or enable this particular port of the driver IC, one needs to be connected here, and then plus 5 supply is also connected to the plus 9 pin of this driver IC. 4, 5 and 13, 12 pins are connected. So it has 4 input pins, pin number 2, pin number 7. So this is one port and this is another port. This input pins, that means pin number 2 and 7 are needs to be connected to the microcontroller, from where we are putting the connection, from where we are passing the command, and this particular pin number 3 and pin number 6 should be connected to the motor. Similarly here 15, this is for second port, pin number 15 and 10 should be connected to microcontroller, 14 and 11 should be connected to the motor, while 13 and 12 are to the ground. So logic 1 or 0 can be used to making this motor on or off. Now let's see how we connect and what should be like, how to connect this motor with the driver IC, and then what logic should be sent to the microcontroller. So let's say we have 8051, this is our 8051 microcontroller, and we want to connect our motor to the pin 1.0, port 1 pin 0 and P1.1. So this will be connected to the driver like L293D IC, and these pins will be one pin number 2 and pin number 7, pin number 2 and pin number 7 of the driver IC, and then we will connect motor here, and this motor needs to be connected to the pin number 3 and pin number 6, pin number 3 and pin number 6. while we have connected all other supplies, like pin number 8 is connected to plus 12 volt as per this, and pin number 9 pin number 9 pin number 1 and pin number 16, pin number 9 pin number 1 pin number 16 has been connected to the plus 5 volt power supply. So this is the complete circuit diagram of connecting this L293D to the 8051 microcontroller. So this is the simplest circuit diagram which we can make. Now in order to make like what should be transferred to this pins of this port 1, now we know pin number 1 and 0 has been connected to the microcontroller. Now when we see 1 and 0 here, so plus 12 will appear here and 0 will appear here. So it will like a motor is running in one direction. If we set command 0 here and 1 here, then this polarity will get changed. So at that time when 0 is at this pin and 1 is at this pin, plus 12 will connect will come at this supply and 0 will come here. So motor will run in the opposite direction. So this is the simple. We just need to change the signal which we are providing to these ports. So now we will send, if we send 0x, okay, we'll learn how to use that. So or let's remember it, 0 and 1 port 1 are connected to the microcontroller, and let's delete it. Now let's see, this is the port 1 pins. So this is 0, this is 1, this is 2, this is 3, 4, 5, 6 and 7. These two pins are connected to the microcontroller. So if we supply 0, 1, motor will connect in will run in one direction. If we supply 0 and 1, then motor will run in opposite direction, and we does not care about the rest of the pins of the port. So we can say all other values are 0, 0. So its hexadecimal code is 0x01 and its hexadecimal code is 0x02. So we will supply simply 0x01 to port 1 and 0x02 to the port 2, and then motor will run in one direction, and then after some time motor will run in another direction. So now let's write the code in Keel software. So let's open Keel and create a new microvision project. So lesson 10, create. That's project. Save, select HTML, it's 89S52 and then OK. Yes. So we will write a code in C language. So let's save it with like DC motor.c. Okay, now saved it. Now let's add to the project like DC motor, add, close. Okay, now let's options for generating take 12 megahertz and output, create hex file, and then okay. So our project has been created. The same, it is very easy to write the same code in assembly, which you can write, I hope, because it is nothing, just sending some commands. So write code hash include reg52.h and then provide the signature of delay unsigned int, and let's start our main program. Void main void. So first we'll write simple while loop. So we are not taking any input, so we don't define anything. So it's very simple. We'll write port 1 equals to 0x01, and then we'll call ms delay 100, and then p1 equals to. If you are directly watching this video, so you can see our previous videos for previous lesson 9 or lesson 8 for learning how to write this embedded C code. So it's done. Now let's write a delay subroutine, ms delay unsigned entity, and then unsigned int I comma j, and then for I equals to 0 to I is less than t, and then I plus plus, and then for j equals to 0 to j is less than 1275, and then j plus plus. If you have any difficulty for understanding what we are doing here, so you can watch our previous lesson 8 or lesson 9 for understanding the same, how to send the code to the port. So let's compile it. Our code is done. So there are 0 error and hex file is created. Now we will check this particular code on our Proteus so that we can see whether our code is working fine or not. So prior to downloading the code into the hardware, let's check on Proteus. So first select this 9C51, and it is selected. Okay. Now let's select DC motor, normal DC motor model, and animated. Now let's connect it. So this is the beauty of this Proteus. We don't need to connect any driver or ground and other supplies in order to make it run. So simply now let's provide the hex file which we have generated. Lesson 10, and this is the hex file one, and okay, so let's run it. So for some time it is running in one direction, and for another time it's running in another direction. Okay, so our delay is very less, and that is why it is not able to move. Let's increase the delay. So instead of 100, let's provide 1000, and let's see, compile it again, and we will choose file again. Okay, now let's simulate it. So it's moving in one direction. It is taking some time to move in Proteus because it has load and inertia, all the things. Now its direction is being reversed. So actually in this model we have accumulated all the real parameters. Let's choose some another model, DC motor, simple DC motor model. So it's running in one direction, and after some time it will move in another direction. Okay, so this is how program we interface our DC motor. So our program is working. Now let's test. Now first burn the microcontroller with the program. So let's open it, and first let's connect and then identify if one has been detected. Let's open the hex file which we want to upload onto the microcontroller. So all the procedure how to burn this 8051 microcontroller using Arduino has been discussed in previous video, and there is a separate lecture or separate web page also that on our website. So you can also download this required software from our website as well, or you can see our previous lessons. For I think lesson 3 or 4 we have discussed how to program this 8051 microcontroller with this Arduino. Let's select the file and open, and then upload hex. So now the code is being uploaded. So it will take for some time. Let's wait for that. It's nearly done. So now let's see how our hardware is responding to it and how motor is running. So this is the PCB of the driver IC circuit. Here this is the IC, and here we have connections. These are connections for input signal from microcontroller, these two pins, and these two pins will be connected to the motor. And here we will connect a +5 supply, and here we will connect a +12 power supply. So now let's connect the connections of this driver IC circuit to the microcontroller. Okay, so we will do it one by one. Okay, so first let's connect a power supply. So this is +5 and this is ground, and this is +12. Now this particular pin is the P1.1 of the microcontroller. It is coming from here. This is coming from here, P1.1, and will connect this particular wire to the D0 of this PCB. And now this, this is P1.0 wire which are connected. Will connect to the second pin. Now connections of this motor, here it is. So it has two connections. This is one. So let's connect it, and this is a second pin. As soon as we connect it, it starts rotating. So now it is taking command from that one, from power supply, and now it's rotating one direction, and now it's rotating in other direction. And after some time it will rotate. Yes. So this is how we can control, or we generally interface this DC motor to the 8051 microcontroller. Now the problem is, if we connect these particular pins of this DC motor directly to the microcontroller, then microcontroller won't be able to run this DC motor because it takes lots of current. So that is why we use this particular driver IC here. So I hope you learn how to interface this DC motor to the microcontroller, and this is very simple. Try at your hand, and if you have some doubts, then you can comment below this video. So we just saw how the response of our program, which we have written in Keil, and to how it works on real machine. Now till now we connected just one DC motor, and as if we look at the connection diagram of this motor driver IC, we can connect two DC motor at a time, and these two DC motor can be connected very easily. If we are connecting two DC motor, let's say what command needs to be sent. So let's say we will connect these two. One motor will be connected to 0 and 1 pin of the microcontroller, and another motor will be connected to a 2 and 3 pin of the microcontroller. So now there could be total 4 combination of these DC motors, like for motor 1 and for motor 2. And if we say send 0, now it will become 0x. If both the motors are running in forward direction, then it will become 0x 05, and it will become 0x0a. So at this case both motors will run in forward direction, and in this case both motors will run in opposite direction. Again, once again, depending on whether we have connected the motors in same direction or not, like because it is not directly mentioned which is positive and which is negative. So in order to verify it, we should check we should check connections, whether both motors are moving in same direction while applying the same input combination to them. So that needs to be done separately, and once that is confirmed, then we can send a simple command like 0101 or 1010 to the microcontroller pins, and in order to run two different motors in same direction or opposite direction. So in our next video we'll learn how to make a obstacle avoidance robot. So in that case we'll using two motors, and we'll learn how to program for that. So that's it for this video. Thank you.